In this video, we're going to do another long division problem with polynomials. So, this is our dividend. This is our divisor, just like last time. And we're going to set up our long division bar. So, on the outside, we have 3x plus 4. And on the inside, we have 27x cubed plus 64. But there's one problem that we have to deal with before we can actually set up our long division bar. If you notice, we do not have anything that's x squared. We only have x to the third and a constant. We have nothing that's x squared, and we have nothing that's x. So, to make this easier for us, we're going to add in a 0x squared and a 0x. The reason we do this is so we don't get messed up when we actually multiply and subtract. We want to make sure we're always subtracting like terms, and we don't make a mistake where we subtract an x squared from an x squared, or an x squared from an x cubed, etc. So this will help make the problem much easier, and now it's actually the same exact type of problem we did in the last video. So before we do these problems, always make sure when you look at your dividend that the exponents of x are all accounted for. So if there's something x cubed, x squared, x, and then a constant, you're good. But if there's something missing, we always have to add in a placeholder when we actually do our division to make sure that we don't make a mistake. Alright, so the same problem as before. How many times does 3x go into 27x cubed? 9x squared times. Because 9x squared times 3x is 27x cubed. We did our division. Now we're going to multiply. 9x squared times 3x is 27x cubed. 9x squared times 4 is 36x squared. Remember, when we're multiplying 9x squared times 3x plus 4, this whole divisor, we need to distribute to both terms. Alright, so we did our multiplication, and now we need to subtract. Instead of subtracting, I always just like to change my signs and add. But you can subtract if that's easier for you. So I make that a positive. I will make the 27x to the third negative, and I will change this plus sign to a minus sign as well. Now it's an addition problem. 27x to the third minus 27x to the third will give me 0. I have 0x squared minus 36x squared, and I get negative 36x squared. I did my subtraction. Now I'm going to bring down my next term, which is 0x. Alright, now I have to repeat the process again. How many times does 3x go into negative 36x squared? Negative 12x times. Because 3x times negative 12x will give me negative 36x squared. Alright, now I multiply my negative 12x times 4. I get negative 48x. Now I have to subtract. But instead of subtracting, I like to add because it's a little bit easier to understand. So I change my sign, I change this sign, and I change this sign. So now it's an addition problem. Negative 36x squared plus 36x squared will give me 0. Now I have 0 plus 48x will give me 48x. And then I'm going to bring down my 64. Alright, last time. How many times does 3x go into 48x? 16. Because 16 times 3x will give me 48x. So, I did my division. Now I'm going to multiply. 3x times 16 will give me 48x. 16 times 4 will give me 64. Now I did my multiplication, and I have to subtract. Instead of subtracting, I like to add, like I said before, and just change my signs of everything else. Alright, so now I have 48x plus negative 48x will give me 0. And now I have 64 plus negative 64 will also give me 0. So now, since I have nothing left, that means I'm done. I did everything right. And my quotient is 9x squared minus 12x plus 16. As you've probably noticed, the process is exactly the same as the first video that we did with this, but we have to make sure that we have the exponents going down in sequence without missing anything. If there's anything missing, we have to make sure we insert placeholders. In this case, the 0x squared and the 0x to account for those terms. So when we actually subtract, we're always combining like terms and not unlike terms.